All right. Good evening, everyone. I think today we want to look at question 4, which is the last question of the second assignment. And in this question, we want to discuss two design patterns. So we are going to talk about design patterns in more detail, but we we want in the meantime to discuss just enough to cover this question. Yeah, to cover this question. All right. So we we want to talk about two design patterns, which is number one, the factory method design pattern, and then number two, the singleton design pattern. And like I said, we are going to talk about these design patterns again when we start doing exam preparations. But for now, let's just quickly understand what this factory method design pattern is together with the singleton design pattern. So we are going to start off by just discussing the factory method pattern, which is a creational pattern, right? So our design patterns are categorized into different categories, which is your creational, your behavioral, and so on. So we are going to touch on that and then list those categories and then talk about which design patterns fall under which methods, right? So the factory method design pattern is used to solve a problem that we have here right now. And let's see the problem first, and then let's talk about how you can use the factory method to design pattern to fix this. As it stands, our widget here is referred to as our client, right? When we want to split our classes based on responsibilities. And what do we mean when we say it's referred to as the client? So our solution right now, if we are going to draw what it looks like, basically we have your registration, your registration class, which is sitting here. Then you've got your student registration, you've got your guest registration, and then you have your registration list, which is sitting there, reg list. These are your classes, right? And then you've got your widget, which is sitting here. Now, this widget here is your graphical user interface or your client. So your client is what interfaces with the user. All right, sorry about that. All right, so your client or your user interface is what the user talks to, right? So your users here are going to be directly interfacing with your application through this, which is then why it's referred to as a client, right? And your widget in turn is going to be using, let me just for simplicity purposes, using these classes. So that's the relationship between your widget and the rest of the classes. So this one is referred to as your excuse me, your client. These are referred to as your model classes, right? Or as your model. Now, not to be confused with Qt's model view programming topic. This is just in general your model classes, because remember, you can actually make another client, which is a console application. You can also make a console and still use these same classes, right? Like it is here. So your client is just how the user interacts with your application. That's your user interface. Now, as it stands, coming back to the problem, your client, if we go to our widget class, which is where we do the ad registration, that's where all the logic sits, which says, go and check what the user wants. If it's a standard registration, then make this instance. If it's a student, then make this registration. If it's a guest, I don't have a guest class here because it's the same as a student registration. I just didn't do it. But that's where all that logic sits. So this is the function that is executed when somebody clicks add registration on the front end. Now, the problem we want to talk about is that your client has to know about all the types of registrations. Now, in this example that we are doing, it might not be very clear why this is necessary because it's a very small application. But if we talk about best practice and good application design in the broader context, you find that you don't want your client to know a lot about your types of registrations because you can add more types, you can reduce, and so on and so on. So as it stands, your client has to know about every single type of registration that exists, which means if we add another registration, we have to come back and add it here and so on and so on. Now, what this means is that between your client and your model, there is what we refer to as tight coupling, right? Which means your 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 client depends a lot on the details of your registrations. It has to know if you go and put another registration, your client has to know. So it's tightly coupled to your registration model. Now, the solution here is to decouple. In other words, you don't want your client to know about types of registrations. You simply want your client to know that there's a registration. What type it is, you don't want your client to care, right? So in order to decouple your client from these registrations here that your client has to know about. So if we were going to draw this maybe in more details, just this simple diagram here, we were going to say that your client has a relationship with your student registration, also with your guest registration, also with your registration. Your client knows about all these three classes. That's your tight coupling. Because if you go and look into your code, yes, my client does know about student registration, does know about registration, and you can see here my client creating instances of registration or student registration or guest registration. If we go and make another one, your client it knows about all these types of registrations that exist, and you don't want that. So what we want to do is to decouple your client so that it doesn't know about the types of registrations that exist. All you want to do is to make sure that your client just knows about a registration. In other words, we want your client to know that there's a registration, it exists, and now there's loose coupling. Now, one way to fix this problem is to introduce what's now referred to here as a factory. Now, your factory class is a class that you create with the sole responsibility of generating registrations. What that means is if your client needs a registration, it goes to the factory and it says, please give me a registration. And your factory is the one that is responsible for creating the actual registration, which it then gives to the client. So coming back here, we are sort of like saying, we are going to make sure that our client does not know about types of registrations. But what we're going to give to our client is simply a factory. So your client is going to know about a factory. This factory is the one that's going to know all about these types of registrations. If we put our relationships here, let me just put this in a different color so it's clear. So your factory is the one that's going to know about all the different types of registrations. Your factory knows about that. Your factory knows about the actual registration. So that's your factory. And then your client simply requests a registration from your factory. So your client is now decoupled from types of registrations. Of course, your client still knows about a registration, but only that it doesn't have an associative relationship now with a registration. So it doesn't actually, yeah, it's now loosely related to a registration instance. There isn't now tight coupling. So whenever your client needs a registration, your client is going to talk to the factory and say, please, can I have a registration? And your factory is the one that's going to give your client an instance of a registration. And that's it. So whether there is 10 types of registrations or 20, your client does not know about the actual instances or types of registrations that exist. All it does is it goes to a registration and says, can I have this kind of a registration? And the factory says, there you go. There is the actual registration. That's what's going on here. So if we come back to our main focus now here is on this factory class, right? If we go back to our code, which we have here, which is where we create our registrations, we are simply saying that we want remember our client wants a registration pointer. And because we understand inheritance, we know that a registration pointer, it can be a student registration, it can be an actual registration, it can be a guest registration. So in this registration pointer, you can store any type of registration. So our client knows that. But only that, this instance is going to be given to us by a factory. So what we are going to do is we're going to say factory maybe dot create registration, for example. It doesn't matter what you call the method, or just create, or yeah, create registration, or just create. And we tell our factory the registration that we want. And this factory is going to return this pointer that we need here, right? And we're going to tell our factory the type of registration that we want. And remember, we've got a combo box on my user interface, which has 3 values: standard, student, or guest. So I'm going to take this value from the combo box and pass this to my factory, right? So I'm going to say, factory, please give me a registration. And there's the registration that I want. So my factory is going to receive standard or student or guest. And then it will give me a registration, which means all this code that I have here, which is deciding which type of registration to create, just disappears, goes, gone. And what I'm going to do now is I'm just going to use a factory that's going to give me a registration, right? And that's it. This code here is simply saying, if I've received a registration, then put it in the list and show a message. Otherwise, just show an error message. That's what I'm doing here. So that's the idea behind the factory, right? And now, because we've got a factory, let's go ahead and create this class and add this method. So factory method, it comes from having a class that is a method which is responsible for creating instances. So this create function that I'm going to use here is the factory method. That's the method which is going to be doing the factoring of the creation of those registrations, right? Okay. So let's go ahead here and make this class. I'm going to go add new class. I'm going to call this class registration factory and go next, finish. Right, here's my registration factory. Inside my registration factory, as you saw earlier, I'm going to now have registration. So this class is the one that knows all types of registrations. I'm going to include registration, then I should include student registration. If I had a guest registration, I was also going to include it here. All of them would be here. And within this class, I'm now going to have a function, which is now my factory method, which returns a registration pointer. Registration, and I'm going to call this function create, as you saw earlier, and it takes a Q string, let's say type of registration. That's my factory class. That's how simple it is. Very straightforward. Okay. And the question is, so how does this create function work? Okay, let's go ahead and implement it. It's doing a very, very simple thing. All it does is it's going to say, if type is equal to standard, then return a new registration instance. Return new registration, like that. right? Else if my type is equal to student, then return new student registration, like that. Otherwise, just return a null value because then you can't make a registration. So that's what my create function looks like. It's very simple, very straightforward. So that's the basic and general idea behind a factory class. Now, if we go back to our widgets here, which is where we were creating our registrations, I want you to take note of one thing, right? Let me just undo everything here. You see that for me to make a registration, I need a person, which is this person here. I also need the qualification, if it's a student registration, or I need the, if it's a guest, there's something that you need, affiliation, right? If it's a guest registration. So my create function cannot make a registration unless it's also given a person, and whether it's an affiliation or um, whatever it is that I need to give it, which is this here, right? Because remember, you've got an affiliation and an email, right? And those are the two things that you need. Yeah, it's either an affiliation or an email based on the question that you're doing. So the idea here is that your create class or your factory method must have enough information to create these instances. So whenever you design your function, make sure that it's got enough information to go ahead and make those instances, right? So what I'm going to do here is make a Q string here, which is going to be my affiliation or my email, whatever it is, right? And then what I'm going to do is, if my registration is a student, then I need to give it this value here, which is my QEdit. QEdit is what? Uh, QEdit is, according to my user interface, where is it now? AF edit, name edit, email edit, P edit. Oh, there it is. That's my qualification. Yeah. So if it's a student, you want to give it your qualification. If it's a guest, you want to give it your affiliation, right? So here I'm making a string that says maybe a qualification or affiliation, whatever it is. And I'm going to say, now this is where you decide how you want to do your function, right? There are different ways you can model your function. You can also do it in such a way that it takes a qualification here and an affiliation here, and your function is going to decide which one to use based on the type of registration being created. Or you can just put one extra variable here, because it doesn't matter if it's according to the factory, whatever it is here is going to be used in the registration being created. But let's say we go for this approach where you go, let me give my create function the person, the qualification, and the affiliation, right? That means the person I've got here, my variable P, let me call this person so it's clear. That's my person that I'm giving to my function. I'm also going to give this function my qualification, which is QEdit, the text, and I'm also going to give it my affiliation, which is AFEdit dot dot text, like that. So that's my function. That's one way you can do it, right? So let me just get rid of all of this. So the idea, the idea behind this is that give your function enough to make those instances. That's how simple it is. So if I'm in my registration factory, I'm simply saying it also needs to know about person. Like that, .h. Here, I think I can also do what is called a forward class reference, but that's for another time. So I can say, give this function your type, give this a person, give this a qualification, give this an affiliation, like that. That's my function. So that's how you design your function. So what to keep in mind is when designing your factory method, it needs two things. Number one, how does it know which instance to return? Number two, have you given it enough to actually create those instances? Okay. So I can go ahead in my factory here and then update my function. And then here, when making a registration, I just need to give it my person, and that's it. When making a student registration, I'm going to give it my person and my qualification, like that. And that's my function. If I'm doing a guest registration, I'd give it my person and my affiliation. That's my function. So that's your factory method. And when you do it like this, you have decoupled your client from your registrations. So all I need to do in my client here is just to define my factories. I can say, you don't know about registration list. All you know about is your factories. I can just go #include registration factory. There you go. And then I can just make my registration factory instance here. So private, if I want, I can put it here. Registration factory. There it is. And this is the factory that I'm using here. And that's it. So when you've done it like this, you have decoupled your client from your registrations. So if you go ahead and add another type of registration, nothing needs to change here in terms of, now I can remove this. I don't need to know about these types of registrations. I don't need to know about guest registration. Your client has no idea what type of registrations exist. And now it's decoupled, good design. If you add another registration, your client doesn't need to change. What needs to change is your factory, because it just needs to be able to handle another type of registration. Forward lookups here, I think I can just go with class person instead of #include. Here it says don't put it here. It wants it to be here. There you go. That's it. So for cases like this, where you're using a class but not calling any of its functions, they recommend that you do this, not #include. So this is what you see in your assignment. If you go up at the top and they talk about recommended practice and all of that, they say prefer to do it like this over #includes. And that's one way, one class where you can actually do it. So whether you go #include person or you just go class person, it references person. So your class now knows about person. And yeah, that's pretty much how you do factory method. So it's all about having a class that can create instances, and you tell that class has a function, which is the actual factory method. You tell that method which instance you want. You give that method enough to make those instances, and it will give you an instance. That's factory method. Now, the next talking point is Singleton. You will notice that in this question, they talked about making your class both factory and Singleton. So we won't talk about Singleton in this class. Let's leave it here, I think. And then we discuss Singleton in the next lesson, which is now converting your registration factory so that it's also an implementation of Singleton. Now, the Singleton design pattern is meant to solve a different type of problem, right? And what this question is showing is that you can have a class that is both factory and Singleton. So what we are going to do next is simply apply the Singleton design pattern to our factory method class. And then we'll see how our code changes once registration factory is now a singleton class. And they say modify the solution in question 3 so that the parts of the solution that we're creating concrete registration objects based on the user input and this are replaced by appropriate code to utilize the registration factory. So this here is referring to the previous question, which uses a SACS reader to create registration objects from XML. So I'll not cover that here. But in other words, this question is simply saying everywhere in your solution where you need a registration, go and use your factory. For example, in this widget here, you want a registration. We don't want to see anywhere else in your solution doing something like this. New student registration, new registration. This should not exist anywhere else in your application except in the factory. If there is any part of your solution where you need a new registration or a new student registration, use your factory for that, which means you're being forbidden from creating instances of registrations anywhere else without using your factory. That's what that part is about, which is basically this line here. So whenever you want to make a registration, that's how you make a registration. Just use your function. Give it the type of the registration, give it the person, give it a qualification and an affiliation, and you get a registration instance. Done. All right, that's it. So, yep, let's meet in the next class, which is the final lesson on this solution, talking about how to make your factory singleton, and your assignment 2 is done. Cheers.